Let's start with the topic of matrices. We will be studying matrices, and later on, we will be using matrices in transformation chapter as well as the chapter of vectors. So, what is a matrix? First of all, matrix is singular and matrices is plural. So, that is the first thing that we should know about it. What we mean by matrix is that we arrange data in a particular manner. There should be some rows and there should be some columns. So the data will be arranged in rows and columns. For example, if I write 1 and 2, so I'll say there is one row, that is the horizontal thing. So row is arranging horizontally and column is arranging it vertically. So that is how we write it. Now, how many rows do we see? We see one row. How many columns do we see? We also see one column. Actually, we don't see one row. There are two rows. This is one, this is the other one. So let me use an eraser over here. There are two rows and one column. So we first write down the order of a matrix. So the order of a matrix is how many rows and how many columns are there. So since in this case, there are two rows, I'm writing rows in blue color. So there are two rows and there is one column. I'm writing column in purple color. So I'm writing it like this. And instead of and, I'm writing a multiplication by sign. So this is a 2 by 1 matrix. Now, maybe there is a confusion with the numbers I have chosen. So instead of 1, let me write 5. Instead of 2, let me write 7. So I have a 5, a 7. There are two rows, one column. We can use the crisscross method, and that is two rows and one column. It's a 2 by 1 matrix. Now, let me label some matrices. For example, let me write A as 4 and 1. Let me write B as -3 and 5. Let me write C as 2 and let's write 5 over here. Instead of 5, let me write something else, 2 and 6. Now, the first concept, let me use a highlighter. That is the concept about scalar multiple. That is a constant multiplying with a matrix. For example, if I want to write 3a, so that is 3 multiplying with 4, 1. This 3 will multiply with 4. This 3 will multiply with 1. So 3 into 4 is 12. 3 into 1 is 3. That is 3a. Similarly, if I'm interested in finding 4b, that is 4 multiplying with -3 and 5. So therefore, we have 4 multiplying with -3, that is -12. 4 multiplying with 5, that is 20. So this is what I get. Let's say I'm interested in multiplying 2c. That is 2 multiplying with 2 and 6. So therefore, this 2 multiplies with this 2. This 2 multiplies with this 6. That comes out to be 4 and 12 over here. So this is 4. This is 12. Now let's say I'm interested in adding 3a plus 4b. So I already have 3a, which is 12, 3. I have 4b, which is -12 and 20. I add the corresponding terms. So 12 is added to -12. And then I have 3 being added to 20. So first thing that I notice over here is that in order for addition, or for that matter, subtraction to take place, the order of matrix should be the same. If it's not same, how can I add the corresponding terms? So when I add it up, what do I get? 12 and negative 12 adds up to 0. 3 and 20 adds up to 23. This is what I get. Now, this time, let me start by taking 3A and 4B and 2C. So let me add it all up. So 3A plus 4B. Actually, let me subtract 2C. So we already have 3A plus 4B, which is 0 and 23. So this thing is already known as 0, 23. Subtracting 2C from it, 2C is 412. 2C is 412. So therefore, again, the corresponding terms, so 0 and negative 4 adds up to negative 4. 23 and 12 adds up to, with a negative sign in between, that comes out to be 11. So minus 4, 11 is the answer. Now, the examiner could have written 3A plus 4B minus 2C equals to P and Q. What are the values of P and Q? So you will say P is negative 4, and then you will say Q is 11. So therefore, P is negative 4 and Q is 11. That's how a simple question can be. So now what you have seen, can you acknowledge it on the WhatsApp group that this addition subtraction concept is there? We have done scalar multiple, and as well as I have done some questions related with addition, subtraction. Order of matrix is the same. So now if this is clear, just acknowledge it on the WhatsApp group. That's the first thing. Okay. Now we will do the past paper questions after we have gone over the concepts. It's a pretty easy chapter. So now let me move to the concept of multiplication, which is kind of tricky. So when we talk about multiplication, we have to take care of few things. We have a matrix A that is 2, 1, 3, and 4. Let me write another matrix B that is 1, 2, and this is 4, 8, and this is 5 and 10. Now, what is the order of a matrix? That is rows and multiplying with column. So let me use a blue marker as I've used for. So rows, let me write column with a purple marker. So how many rows do we see? In the first matrix, this is one row, and this is the other row. Over here, again, it's one row, it's the other row. What about the columns? One column and one column, and then one column, another column, another column. So first of all, if I talk about matrix A, so therefore A has how many rows, how many columns? It's a 2 by 2 matrix. There are 2 rows and 2 columns. First, we have to write the rows and then the column. That is the order of a matrix. When I talk about B, there are 2 rows, but now we have 3 columns. So this is 2 by 3. So let me write row of A. This is row of B. This is column of A. This is column of B. Now the rule is, in order for multiplication to take place, the rule number 1 is that the column of matrix A should equal rows of matrix B. The order matters. So column of matrix A should equal rows of matrix B. Is it equal? Is 2 equals to 2? The answer is yes. That means multiplication is possible. Now, let me think for a second. What if I'm interested in multiplying out B and then A? So this is 2 by 3, and A is what? That's 2 by 2. So these two are unequal, so multiplication would not have been possible. That's the first standard. So let me highlight this again. So rule number 1, let me highlight it over here with a black marker. Rule number 1. That is, column of matrix A should equal rows of matrix B. If it's equal, then we can proceed. Otherwise, we have to stop. Now, rule number 2. That is another important rule. That is, how would the answer matrix looks like? Now, what is left? We are left with row of A. We are left with column of B. So the order of the matrix is what? That is row of A multiplying with column of B. Whatever is written in that particular order, that is the answer for this particular part. So now let me copy down this matrix. A is 2, 1, 3, 4. Let me write it over here. A is 2, 1, 3, and 4. Let me write B, which is 1, 4, 5, 2, 4, 2, 8, 10. So B is 1, 4, 5, and this is 2, 8, and 10. And let me find the matrix AB. Now we have already double checked. Yes, it's multiplicable. So 2, 1, 3, 4, multiplying with 1, 2, 4, 8, 5, and 10. Now let me use a highlighter again. So blue is for rows and purple is for column. So when I multiply, I'll take one row, one column, and I'll get one answer. And in which order will it multiply? It will multiply like this. The 2 gets multiplied with 1, and this 1 over here gets multiplied with this 2. So let's get started with this. So first of all, 2 into 1, 1 into 2. Let me write it. 2 into 1 plus 1 into 2. That is this answer. I'm starting to write down the answer for this matrix. Let's keep this thing constant. That is the row constant. Now keep on changing the column. So let me write 4 and 8. So I'm moving to the second column. First, I got started with the first column. Now I'm moving to the second column. So now let's multiply this thing again. So this 2 and this 4 and this 1 and this 8. So let's multiply. That's 2 into 4 plus 1 into 8. Put it inside a bracket. The third one, let me write 5 and 10. That is the third column. We will repeat the same process. It seems long, but it's not. We will repeat the same process. That is, let me choose a different color over here. That is, let me choose, hold for a second. Let me choose this 2. Let me multiply with 5. Let me choose this one, multiply it with 10. So that is 2 into 5 plus 1 into 10, and we add it up. That is how we use this row with each column individually. And since we started off with the row, the complete row will be filled up. So I have basically filled up this thing. And then this thing. and then this thing. That's how it's being filled up. I think everyone got the point loud and clear. I multiplied it out. I then got this. I then got this. So basically, this whole thing is completed. Now, I'll simplify it later. Let me move to another color, another version of blue. And now I'll take this thing. That's this one. And then I'll repeat the process with this one first of all. So now, how will we proceed? We will write this 3 multiplying with 1, this 4 multiplying with this 2. So that is 3 into 1 plus 4 into 2. You can use brackets. Brackets are for free. Use as much as possible. Similarly, let me choose another color. That is use 3. Let me choose this blue color. Use 3. Use 4. Use this 4. Use this 8. So that's 3 into 4, 4 into 8. 3 into 4 and 4 into 8. Let me use orange color. That is this 3 and this 3 goes with this 5. This 4 goes with this 10. So that's 3 into 5 and this is 4 into 10. And let's simplify. So this is the working that we have done for this column, this column, this column. Now double check. What does the answer looks like? The answer looks like row of first a matrix, that is 2, and column of second matrix, which is 3. So this is 2 by 3, which is the case over here. So this is a 2 by 3 matrix. Yes, it's a 2 columns, 2 rows and 3 columns. That's how the answer will look like. Now I'll simplify. 2 into 1 is 2. 1 into 2 is 2. 2 plus 2 is 4. 2, 4, 8. 1 into 8 is 8. So that is 16. 2 into 5 is 10. 1 into 10 is 10. So that is 20. 3 plus 8. That is 11. 12. And this is 32. So that is 44. And this is 40. This is 15. That is 55. That's how the answer looks like. That is how multiplication of matrices is done. Now, again, acknowledge on the group if this is all good. The multiplication part of matrices. So now we have understood addition. We have understood subtraction. For addition and subtraction, the order has to be the same. When we talk about scalar multiplication, that is a constant multiplying with a vector. So it multiplies with each member. When we talk about multiplication of matrices, we know that row, column, matrix A, matrix B, these two should be the same. And that's how the answer will look like. Now let's talk about something else. Let's talk about the concept of determinant first. So let me take the same matrix, which is A, 2, 1, 3, 4. So let me write A, that is equal to 2, 1, 3, 4. And when we talk about determinant, we specifically talk about a 2 by 2 matrix only. We only talk about this thing because that's in the syllabus. Now, if we talk about this and this, and then let me talk about this and this. Actually, let me label it as the letter M. And let me write M as A, B, C, and D. Now, in place of A, I have 2. In place of D, I have 4. In place of B, I have 1. In place of C, I have 3. Now let me evaluate AD. So AD is 2 into 4, which is 8. Let me evaluate BC, which is 1 into 3, which is 3. Let me evaluate right determinant of matrix M, which is AD minus BC, determinant of M, that is 2 into 4 minus 1 into 3, which is 8 minus 3, which comes out to be 5. That is how determinant is evaluated, AD minus BC. That is the standard. That is something that people, even when they reach A levels, they remember this thing, because this is something very, very basic. People like to remember it. Remember the arrows, AD, remember the arrows, BC, and subtraction. Go this way first, go this way, and then subtract. Now, let me get started with the concept of inverse of a matrix. Inverse of a matrix, and then we will talk about its properties. Now, the inverse of a matrix, M inverse, is 1 over determinant of M, and then these change places. So let me shift this thing over here, and then I can write the working underneath it. So we know that, what do we have? We have A and D. So these two change places. So this is D goes over here, A goes over here, the places are changed. And then what about B and C? So B and C, they change sign. So blue color, let me just double check. It's all good. So now I'm interested in the blue color, that is minus B, that is minus C. So the red one, change places, positions diagonally. The interchange, that is a better word. The interchange places. And what about the blue one? Change signs. And then on the outside, this is 1 over determinant of M. So let me evaluate it. So M is what? That is 2, 1, 3, 4. That is 2, 1, 3, 4. What is determinant of M? That is 5. What is M inverse? So let me write it like this. So this is red color. This is red color. They change places. So 4 goes over here, 2 goes over here. The blue ones, 1 and 3, they change signs. And the purple thing, 1 over determinant, that is 1 over 5. That is how we find the inverse. So now let's involve some multiplication with inverse of a matrix. So let's go to the next page. So let me just pick this thing from here. And this thing is copied and it's taken to the next page. I'm writing this on this side. And let me actually, I need to put it on another page too. So maybe the middle of this page is perfect. Okay, this is good. And let me just think that's M inverse. And let me write it over here. Now, first of all, what I'll do is that, let me just push it up a bit. And I'm interested in multiplying a matrix and its inverse, not someone else's inverse, its inverse. Now, this is the heading, so this should go up like this. And let's see what is the order. Now, this is a 2 by 2 matrix. This is also a 2 by 2 matrix. I can take this 1/5 on the inside also. I can leave it outside, doesn't make a difference. This is 2 by 2. This is 2 by 2. This equals to this. The answer is a 2 by 2 matrix. Yes, it's multiply. It can be multiplied. Now, the first option, that is, I'm multiplying M with M inverse in this order. So I'm writing 2, 1, 3, 4. I'm multiplying it with 4, -1, -3, and 2. And I'm writing this 1/5 on the outside. It doesn't make a difference. This doesn't make a difference. Now, let me, and this is column. We will multiply it this way. And then we will multiply this way. And then we'll proceed. So if I multiply, 1/5 remains as it is. This 2 into 4 and 1 into -3. So this is 2 into 4 plus 1 into -3. Then this 2 into -1, this -1, and then this 1 into 2, and then this 1 into 2. That's done. Let's move to the next column. So let me choose the blue color again, and this time thicker. So this time I'll be multiplying 3 with this 4, and this 4 with -3. So this is 3 with 4, and this 4 with -3. And then again, this 3 with this -1, this 4 with this 2. So this is 3 with -1, and this 4 with 2. Now I can use a multiplication sign, or I can just write 2 and 3 like this. It doesn't make a difference. This is 2, this is 3, and it's your choice. Now let's simplify. 1/5 is on the outside. And first of all, 2 into 4 is 8, 1 into -3. So 8 minus 3, this is 5. And over here, -3 and 8, that is also 5. Now we'll observe something. And -2 plus 2, that is 0. And this is 12 minus 12, that is 0. And let me just shift this 5 over here. Let me shift this bracket over here. Can you see this bracket? Now there's 1/5 over here. There are 2 zeros. There are 2 5s. 1/5 of 5 is 1. 1/5 of 5 is 1. So therefore, this simplifies to 1, 0, 0, 1. This is called an identity matrix. I for identity. This is known as an identity matrix. That means whenever a matrix is multiplied by its inverse, I'll get an identity matrix. That is the first thing. Now, someone can raise this question. What if I change the order? Let me multiply M inverse with M. Will I still get an identity matrix? No harm in checking it out. So now this is 1/5. This is 4. This is -1. This is -3. This is 2. Multiplying with 2, 1, 3, and 4. Again, I'll repeat the process. So this column, and let me do it one by one. And then this row, and then this row. So first, let's get started with this 1/5. Big bracket, 4 into 2 and -1 into 3. 4 into 2 and -1 into 3. And then 4 into 1 and -1 into 4. 4 into 1 and -1 into 4. Use as many brackets as possible. Just take care of the positive, negative sign. Now let me move to the next column. That is this one. And then I'll work out with these two. So -3 into 2. and this is 2 into 3. And this is negative 3 into 1, and that's 2 into 4. Let's simplify. This is 8 minus 3, which is 5. This is 4 and negative 4, which is 0. This is negative 6 plus 6, which is 0. This is negative 3 plus 8, which is 5. Aren't you getting exactly the same thing which you found before, which is an identity matrix? Yes, you are getting exactly the same thing. That means, what is the conclusion? The conclusion is, whether you multiply a matrix by its inverse in any order, you will be getting 1, 0, 0, 1, which is an identity matrix. And this is something very important that we can use later. Now, let's say I take a matrix. Let me take the same matrix, which is M and M inverse 2, 1, 3, 4. M is 2, 1, 3, and 4. M inverse is 1/5. 2 and 4 change places, and these two, it changes sign. Now, let me take a matrix. Let me write it as A. And this is 4, 6. Okay, this is 4, 6. Now, let me multiply out MA, which is 2, 1. So let me write it in black color. That is 2, 1, 3, 4. And this thing in blue color, which is 4, 6. Can they be multiplied? This is a 2 by 2 matrix. This is a 2 by 1 matrix. This is 2 rows, 2 columns. This is 2 rows, 1 column. Can it be multiplied? The answer is yes. Why? Because these two are exactly the same. And the answer will look like this, 2 by 1. That means 2 by 1. That is how the answer will look like. It will have 2 elements like this. That's also another way of checking it. Again, let me emphasize this. This is 2. This is the row. This is the column. Let me multiply it out. So that is 2 into 4 plus 1 into 6. Since there are no more columns, I'll just stop over here. Let me move to the next one. That is 3, 4, multiplying with the other two. So that is 3 into 4 and 4 into 6. Close the bracket. That is 8 plus 6, which is 14. And this is 12 plus 24, which is 36. Now, let me make a question out of it. How can an examination question be made out of it? Understand the process. The examination question can be something like this. They can give us matrix M, which is 2, 1, 3, 4. And they can give us A, which is 4, 6. Actually, no. They can give us MA. That is 14 and 36. And they can ask us, find A. Now, remember, there is multiplication in matrices. There is inverse in matrices. There is the concept of M into M inverse is the same thing as identity matrix, which is M inverse into identity matrix. And identity matrix multiplying with any matrix, if multiplication is possible, the matrix remains unchanged. Now, that is something very important. For example, let me write 1001. Let me write 1, 2, 3, 6, 5, 10. And if I multiply it out, so this is 1, 0, and then the first column, then the second column, then the third column. First of all, this is a 2 by 2 matrix. This is a 2 by 3 matrix. Row, column, row, column. These two are exactly the same. Yes, multiplication is possible. The answer will look like this, which is 2 rows and 3 columns. So 2 rows and 3 columns. So you will get 6 elements of the matrix like this. Now, let me simplify this. 1 with 1 and 0 with 2. So basically, it's just 1 multiplying with this 1. The 0 will make everything 0. So 1 into 1 is 1. And then 1 into 3 is 3. And then 1 into 5 is 5. The first 3 numbers are like this. That's the thing that you get. And on the other side, if I have 0 and 1, so this 0 into 1 will make it 0. This 1 into 2. This 0 into 3, 1 into 6. 0 into 5, 1 into 10. So basically, this 1 is multiplying with 2 and 6 and 10. So 1 is multiplying with 2 and 6 and 10, and double check, it's the same as before. Now, coming back to this is something kind of a little bit tricky. Find A. So now the thing is, there is no division. So we will work it out this way. So this is the question. This is the problem that we have. And we are interested in working out the solution for this. So we will write MA equals to, instead of 1436, let me write B over here. And B is given. Let me shift it over here. Over here, find A. Let me shift it over here. And we are given B as 14 and 36. So this information is given. This information is given. This equation is given. MA equals to B. Find A. Because M is given. B is given. We are interested in A. Now, if I write MA equals to B, so we want to get rid of this M. So what we do is that we pre-multiply. We cannot insert anything in between. We pre-multiply inverse. We pre-multiply by M inverse on both sides of equation. Now just have a look. And then once I'm done, then things will be a little bit more clear. Now we know that M inverse is over here, 1/5, 4, 2, minus 1, and negative 3. So first of all, let me write M inverse is 1/5. And these two change places, 2 and 4 change places. So that's 4 and 2, and negative 1 and negative 3. This is M inverse. So I'll write M inverse MA is equals to M inverse B. This becomes the identity matrix. Multiplying with A will simply become A. So you can write this thing on the other side. There is no working to show, except you will write 1/5. You will write 4, 2, negative 1, negative 3, and you will multiply it with B. What is B? That is 1436. And let's multiply it out. So this is 4 and negative 1. It's multiplying with 14 and 36. So therefore, 1/5 is on the outside. 4 into 14, that is 56. Minus 1 into 36, that is negative 36. This is one element. And then let's move to the next row. That is -3 and 2 multiplying with these two. So -3 into 14, 2 into 36. So -3 into 14 is how much? -42. And 2 into 36 is 72. Now, this is 1/5. A difference between 56 and 36 negative is +20. And over here, the difference is +30. So 1/5 of 20 is 4. 1/5 of 30 is 6. So the answer of A is 4, 6. Let's double check. There it is. We have just used this result to create this question. I wrote M, I wrote A, I multiplied M with A, I got 1436. I created the exam question. M is this thing. Answer I have written as B is this. This equation, this relationship is given. Given that MA equals to B, find A. What is the solution? The solution is pre-multiply. M inverse MA is equals to M inverse B. So you make A the subject. And M inverse of B. That's one way of thinking. Someone can say, can we write MA equals to B, divide both sides by M? Well, technically, it's not correct, but you can. So B division by M, M inverse goes at the top, but it has to come up front. So it is necessary because this is a 2 by 2 matrix. This is a 2 by 1 matrix. Sorry, this is 2 by 2. This is 2 by 1. So these two are the same. Then the answer is 2 by 1. 2 by 1. If I write 2 by 1 and 2 by 2, multiplication won't be possible. And naturally, you won't get the correct answer. So that is the logic that we apply. And that is all about the theory of matrices. Now, just acknowledge on the WhatsApp if this is all good, all clear. Now, there are some paper 1 questions and then some paper 2 questions. This is the page of that topical book that's in the Google Classroom. And naturally, some questions have been attached over here also. So now let's look at this question. They will involve everything that we have studied. Now, question number 16. A is 5, 3, -2, 0. B is this matrix. Find A minus 2B. Find A inverse. Simple question. Let me explain it to you. So now, first of all, if I start with part A, so this is part A, I'm focusing A minus 2B. So let me write 2B over here. That is just doubling every element over here. So that's 2, that's 6, that's 4, that is -6. That's 2B. And then if I'm interested in A minus 2B, so therefore this is 5, 3, -2, 0, minus, and 2B is already here. That is 2, 6, 4, and -6. Now add up the corresponding terms. 5 gets added to 2, 3 gets added to 6, -2 gets added to 4, and then 0 gets added to -6. So the answer is what? 5 and 2 becomes 7, 3 and 6 becomes 9, -2, negative, actually, there is a negative sign, which I forgot. So don't forget this negative sign over here. 5 minus 2, that is 3. 3 minus 6, -3. -2 minus 4, -6. 0 minus -6, which is +6. That is the answer. Write it in the space provided. 3, -3, -6, +6. What about the next one? That is A inverse. So A, write it again. That is 5, 3, -2, 0. 5, 3, -2, 0. What is determinant of A? Which is 5 into 0 minus 3 into -2. This is 0, this is negative, this is -6. That comes out to be +6. So write 1/6, 1 over determinant over here. These two change places. So 0, you write it over here, and 5, you write it over here. 3 and -2 change sign, that is -3, and this is +2. And there is no need of multiplying this on the inside. You can leave it on the outside. If you want to multiply, there is no harm in that also. So this is 0. This is -3/6. This is 2/6. This is 5/6. So you can also write it like this. That is your choice, whether you want to write it like this or you want to write it like this. That's your choice. So now this thing is done. Now let's look at 15 part A. Now it's a concept regarding, it's a question regarding the concept of determinant of a matrix. Find K. So what do? We multiply K with 2. These two gets multiplied. That's right over here. And then there is a negative sign. You multiply these two, 5 and -1. So that is 5 and -1. That's right over here. And we equate it to 14. So 2K plus 5 is 14. 2K equals to 9. K comes out to be 9/2 or 4.5. Since this is simple, so you can write it in decimals also. Otherwise, fraction is more preferable. So now in these questions, there is no hurry. It's for 1 mark only. So one simple mistake and you lose your marks. So show every bit of working. Now, some people, they say that working is not necessary for a 1 mark question. It's perfectly right. Working is not necessary, but what are your chances of getting it right without showing the correct working? So you have to show the working, whether they are giving you the marks for that or not. So working is necessary. Find the inverse of this matrix. I think that is pretty basic. I'm skipping this. Now, let me explain part A. So there are certain parts on which I'll be focusing. So for example, I'm focusing on this part. I'm focusing on this part. Let me write this thing. Now it says 3m plus 4 times this thing is equals to m. Find m, expressing it in this form. So basically, why don't we make m the subject first? So this is 3m, this is m. Can I write this thing as 3m minus m, which is 2m? And this is plus. And let me multiply this out, 4 with each one of them. So 4 into 2 is 8, 4 into -1 is -4, 4 into 3 is 12, 4 into 0 is 0, and this equals to 0. So therefore, 2m equals to, take it to the other side, this becomes negative, and this is 8, and this is -4, and this is 12, and this is 0. Now keep in mind, this positive goes to the other side and becomes negative. The terms on the inside, the elements on the inside remain the same. Now make m the subject. So if I make m the subject, that is minus is there on the outside, 1/2, and this is 8, and this is -4, and this is 12, and this is 0. So now just do halving of it. So therefore, what's the answer? -half of 8 is -4. -half of -4 is +2. -half of 12 is -6. -half of 0 is 0. That is the answer for this particular part. The next question is basic. That is why I'm skipping this. That is the inverse of this matrix that you can easily find. Now let's move on. This is also something very basic. Now, this is what I'm interested in. Now it says a word problem. So this time we have a word problem based on matrices. And yes, you have to use your brain in this particular one in about thinking how things proceed. A business makes toy buses and toy lorries. The following table is used in calculating the cost of making each toy. Labor cost $10 per hour, wood cost $1 per block, and paint cost $P per 10. So now let me use 3 colors over here. So let me choose labor in red. That's $10 per hour. Actually, let me I'll label it like this. And then in green color, I'm interested in the wood, and then paint in purple color. So there is labor, that's over here, and wood, that's in green, and paint, that's in purple. And then there are buses and lorries. So this is for buses, the orange color, and for lorries, I can choose the blue color. Okay. So now this is the data that you can see. Now, what do we see over here? This is the number of labor used in making a bus, that is 2 hours. For wood, I'll be needing 3 blocks. In making a bus, I'll need 1 tin of paint. For a lorry, I'll be using 1 hour of my time. I'll be using this many blocks, that is W. I'll be using 2 tins of paint. That is how this will be read. The information above can be summarized in the matrices A and B. Matrix A, this is 2311W2. 2311W2. So this is for the labor hours. So let me highlight it. So this is 2 and 1. That's for the labor. So that's 2 and 1 for the labor. And for the wooden blocks, that's 3 and W. For the paint, that's 1 and 2. And what is B? That is 10, 1 and P. What is this? This is the rate. So this is the labor cost, which is right over here. This is the labor cost per hour. Take it. So that's per hour. This one, that is wood cost per block. And this P is what? That is $P per tin. That is what is over here. Now, given that AB is this much, find P, find W. Now, first of all, let me write. This is 2, 3, 1. That is 2 and 3 and 1 and 1 and W and 2. It's multiplying in the order because A is in that is 10, 1 and 1. Answer is up to 28 and 24. Now let me double check. How many rows, how many columns? 2 rows, 3 columns. So let me write over here for matrix A, that is 2 rows and 3 columns. What about over here? 3 rows, 1 column. So over here, this is 3 rows and 1 column. This is matrix B, and this is matrix A. Can it be multiplied? The answer is yes. This is 3 columns. This is 3 rows. They are equal. It will be multiplied. How would the answer look like? That would be 2 rows, 1 column. That's right over here. 2 rows, 1 column. That is perfect. Now, if I multiply it out, so let me just take this thing and move it to the next page because I want some more space. So let me paste it over here. Okay. Now over here, when I multiply it out, again, the rule is the same. That is rows and that is column, like this. So multiply each corresponding element. 2 gets multiplied with 10. 3 gets multiplied with 1. 1 gets multiplied with P. So first of all, I'll multiply. That is 2 into 10, 3 into 1, 1 into P. That is the first thing. Let me move to the next column again. That's 1 and W and 2. So this 1 gets multiplied with 10. W gets multiplied with 1. 2 gets multiplied with P. So let me write it down. that is 1 into 10, W into 10, W into 1, not 10, W into 1, perfect. And this is 2 into P. And let me close the bracket. And this equals to 28 and 24. So if I simplify, that's 20 and that's 3 and that's P. So 20 plus 3 plus P, and the other one is 10 and W and 2P. 10 and W and 2P. This equals to 28 and 24. Now, two matrices are exactly the same. That means this should equal to this. That means this should equal to this. So if I focus on the green one and the orange one separately, what do I get? I get 23 plus P equals to 28. Therefore, P comes out to be 5. Over here, 10 plus W plus 2P equals to 24. 10 plus W plus 2 times 5 is 24. 10 plus W plus 10 equals to 24. W plus 20 equals to 24. Therefore, W comes out to be 4. And that is what is being asked. Find P, find W. What is P? P is the paint cost, P dollars per 10. That means the cost is $5 per 10 if they were asking me to write 100 words. What is W? W is the number of wood blocks needed to make a lorry. So therefore, 4 blocks are needed for making 1 lorry. Okay, so now this thing is done. I hope it's clear to you. It's a beautiful question. And then it says, evaluate this thing. 100, 200, 28, 24. Explain what your answer to part 2 represents. So now 100, 200, and this is 28, 24. So again, this is row, this is column. So therefore, this is 100 into 28 plus 200 into 24. So that is 2800. And this is 4800. And basically just add 28 and 48. So that is 50 plus 26, that is 76. So this is 7600. Now, first of all, what does it represent? And even before that, they did not ask us, but we need to know what does 28 and 24 represents. This 231, that is the number of hours and the number of blocks and the number of panes, and this is the cost. So this 28 is the cost for making a bus. That's right over here. This labeling for row is the answer. So this 28 is the cost for making a bus. And this is the cost for making a lorry. Do you get the idea? Now just double check. This is our labor is 2 hours for a bus. So labor cost is 10. 2 into 10 is 20. 3 blocks, that's 3 into 1, that's $3. Paint is 1, and we found the value of P is 5. So 1 into 5 is 5. So 20 plus this 3 plus 5, that is 28. That is evident more than before. So this is the cost of a bus. This is the cost of a lorry. So what is this? This is basically 100 buses. And this is 200 lorries. And we are getting one answer. That means this is the total cost of 100 buses and 200 lorries. That is what we are getting. So we are getting this answer as P is already found. That was 5 and W was 4. P was 5, W was 4. Part 2 was 7600, and this answer is the total cost of 100 buses and 200 lorries. That is the answer for this part. And here is the mark scheme. That is 370. That was the first part, which I skipped. P is 5, W is 4, 7,600. Total cost of making 100 buses and 200 lorries. And that is all good over here. Now, there is one question over here. I would like you to try it out. Take 2 minutes and try it out. Now, let's look at this question, very similar to the example that we just studied. The question says 2 families ordered 3 basic food items from the local shop. The Jones family ordered 1 bag of sugar, 4 cartons of milk, and 3 loaves of bread. So now let me highlight this. This is the Jones family. 1 sugar, 4 milk, 3 bread, and I can highlight it like this. 1, 4, 3, that goes like this. And then there are the other family, that is the Singh family. They ordered no sugar, 3 cartons of milk, 5 loaves of bread. So that is 04035. That is this for the Singh family. Their orders can be represented by this matrix A, where A is given as such and such. It's 3 rows and 2 columns. This is a 3 by 2 matrix. The cost of a bag of sugar is 80 cents. Carton of milk is 50 cents. Cost of a loaf of bread is 40 cents. The information can be represented this way. So now we are talking about cost of a bag of sugar is 80, carton of milk is 50, and cost of a loaf of bread is 40. And how is it represented? As 80, 50, 40. That's it, represented like this. Work out BA. What does the matrix BA represents? I think without any working, I can say it would be representing the total cost. Let's see. So I'm writing 80 and 50 and 40 first. I'm closing the bracket. And then A is 143035. So this is 1, 4, 3, and 0, 3, and 5. So now I know that I have to take, hold for a second, I need a highlighter, a green color like this. This is row. And in orange color, I'm writing the first column, and then the second column will come. Now, let me also write, what is the order? That's 1 row and 3 column. So this is 1 row and 3 column. This is for matrix B. And then for matrix A, this is what? This is 1, 2, 3, 3 rows, 2 columns. So this is 3 rows and 2 column. This is for matrix A. Since these two are exactly the same, the answer would be 1 row and 2 column. So the answer would be this. That is 1 row and 2 column. These two are exactly the same. So multiplication is possible. Always do double check this. Now let me multiply. 80, 50, 40 will be multiplied in this order. So this is 80 into 1. This is 50 into 4. This is 40 into 3. This is the first thing. That is what you get. And this is 1 row and 2 columns. So this is 1 row and 2 column. Let me move to the second one. Now 80 with 0, 50 with 3, 40 with 5. 80 with 0 and 50 with 3 and 40 with 5. And let me close the bracket. Let me simplify. It's a paper 1 question. That's 80 plus 200 plus 120. 80 plus 120, that's 200. 200 plus 200, that's 400. This is 0. This is 150. This is 200. So that is 350. What do you think it will represent? We are dealing with 2 things. We are dealing with 2 families, right? And basically, what is happening is that This is the cost, and this is the requirement of one family. The first family is which one? That's the Jones family. So this answer is for the Jones family. And the other color I've chosen is blue color. That is for the Singh family. So this is the, what are we looking for? This is the cartons and milk and this thing cost. So this is the cost for grocery. The other one is also the cost for grocery. And the first one is the Jones family. And I think the blue one is the Singh family. So this is the cost for each family. That is what it represents. Let's read. That's 400 and 300. Okay. Now, one thing, I made a mistake. Let me correct myself. That is over here. That is, let me just stroke eraser like this. And first of all, the mistake, what is the mistake I did? This is one row, my bad. This is one row and two columns. So it should be one row and two columns like this. So I wrote in the wrong order. So this is one row. So that is 400 for this one. And the other one is for Singh. That is 350 over here. So this is one row and two column. This is 400 and 350. Total cost for each family's order. That means 400 is for Jones and 350 is for Singh. And there are many more questions like this. For example, let me look at this question. Find the matrix Y where YA is 6, 2. Now, this is that thing. So this time, I need to solve this thing. Let me highlight this one, part C. YA is equals to 6, 2. So YA is 6, 2. And let me write 6, 2 as B. Let me make it a more complex question. So B, this matrix over here is the matrix B, which is 6, 2. I'm writing it like this. And I need to find the matrix Y. Now, this is post-multiply. Before that, it was pre-multiply. This is post-multiply. Why? Because the unknown is Y. And then A written. So we post-multiply both sides by A inverse. So we write A inverse over here. We write A inverse over here. We know that A into A inverse is an identity matrix. Identity matrix will let Y remains as it is. This is B into A inverse. So B is 6, 2. And A inverse, I can find out very quickly. So this is A over here. Determinant of A, that's 3 into 2 minus 1 into negative 1. That is 6. And this is positive 1. This is 7. So therefore, A inverse is 1 over 7. These two change places, 3 and 2. And these two change sign, negative 1 and positive 1. So this is 2, negative 1, 1 and 3. And 1 over 7, I'll multiply it at the very end. It doesn't make a difference. Now let me take 6, 2. Let me multiply it with 2, 1. So first of all, also double check. This is 1 by 2, 1 row, 2 column. And this is 2 by 2, 2 rows, 2 column. And what do we have? We have these two as equal. The answer will be 1 row and 2 column. So 1 row and 2 column, just like the above. That's how the answer will be. So now, this is 6 multiplies with 2, 2 multiplies with 1. So 6 into 2, that's 2 into 1. That's the first thing. And then let me multiply these two. That is 6 and 2 multiplying with negative 1 and 3. So 6 multiplying with negative 1, 2 multiplying with 3. And let me simplify it. Don't forget, there is a 1 over 7 on the outside. I can write it at the front. 6 into 2 is 12. 12 plus 2 is 14. So this is 14. And this is 6. And this is 0. It's 0 over here. It's 1 over 7. So 1/7 of 14 is 2. 1/7 of 0 is 0. The answer is 2, 0. This is the matrix Y. So this is 2, 0. And this is the answer that we are looking for. So that gives you a complete idea of what matrices is all about. The same kind of questions are there in paper 2 also. You can skip this one because this by mistake is about transformation that we will study later on. And then all these questions can be tried easily. That completes the concept of matrices in one single class.